Monitoring procedures, vegetation measurements, vegetative cover, part of the Rocky Mountain Field Institute Citizen Science Training. As a volunteer citizen scientist, your role will be to collect measurements once a month. We will start our measurements in the Garden of the Gods, and all the equipment you need will be provided for you. After watching this video, you should be able to collect vegetation data, specifically vegetative cover data, using a Quadrat method. The data collection objectives addressed in this video are to measure vegetative cover on social trails. To meet this objective, we need to understand a couple of terms that we're using in this context. Social trails are unplanned trails that occur either adjacent to existing trails or in areas closed to protect sensitive landscapes and/or wildlife habitat. Here in this picture, we can see here a trail going through a nice valley, which is great wildlife habitat, but we have redundant trails all around. We don't need one right here, and we can certainly do without several trails going to the same place. In this video and in this measurement environment, we will talk about percent cover or vegetative cover. This is a systematic measurement of vegetative area divided by the total unit area. Our unit area is the quadrat. We'll talk about that in a minute. The opposite of percent vegetative cover would be the percentage of bare ground. This measurement is often used in rangeland management to characterize the health of the range in very general terms. So, in our field science knowledge, we need to understand what a transect is. A transect is a line along which measurements are taken. This can be random or systematic. We want to ask ourselves questions whenever presented with a concept to find out more about it. So in terms of the transect, we want to think, where will it start? Where will it end? What will you measure along the transect? And how will you know when you've sampled enough? We will use two kinds of transects, the longitudinal measurement of a restored trail and the longitudinal measurement of a social trail profile. So we looked here at this video, or this picture in another video. There's an example of a social trail crossing the valley. We are going to sample every 30 feet for the entire trail section restored. So in the context of vegetative cover, we're going to lay the quadrat down every 30 feet for the entire trail section restored. We are only interested in the effects of Rumphi's restoration work, so this limits our transect parameters. So along the transect, when we are measuring vegetative cover, we will use a quadrat. A quadrat is a square with cross lines. The lines delineate a regular area in intervals. It doesn't actually matter what the area is, but that the division created by the lines make equal-sized portions within the larger framework. We'll use the quadrat to measure percent cover of vegetation on social trails. This sounds simple, but there are lots of ways to interpret this measurement schema. All the decision points need to happen, all the protocols need to be established prior to the measurement effort. If you decide what you're going to do, you will do it repeatedly, month after month. It's not so much what you do, but that you repeat it that makes the data reliable. So let's look at our quadrat. This is our quadrat. It's a very simple design, made with PVC pipe and some twine and some duct tape. The quadrat's dimension is a 2-foot square. The reasoning behind this is that the standard footpath is about 18 inches wide. This would be a naturally occurring trail, and we will lay the Quadrat on top of any social trail, and 2 feet should cover its width in most situations. In our Quadrat, there are 100 squares, 10 squares in each direction. Each square is 2.4 inches square, but this doesn't really matter because we will report percent cover. Percent cover will translate very easily with our Quadrat. Each square is 1% of the total. So if you add up the squares that contain the plant, you'll know already what the percentage of cover was. So an example of a decision point is the question, what does contain the plant mean? Okay, so you've been instructed to count up the number of squares that contain the plant. For our measurements, contain the plant means that the square that we are interested in knowing how many squares in which the plant is attached to the ground and/or in which live plant matter is shading the ground. If dead vegetation is just laying in a square, it doesn't count. So let's practice. How many squares contain seed pods? So these are seed pods right here. Oops. These right here. Okay. If you count presence or absence per square, what is the percent cover? If the seed pod is, quote, in the square, is it just in the tiny corner of the square? Does that count? Or does it have to be totally in the square? These are the questions you need to ask yourself. If you estimate what percentage using each square as a frame of reference, then you're asking what is the percent coverage averaged across the squares within the larger Quadrat. So in this example, there are 9 squares. So each square is approximately 11%. Okay, so we can go through and we can say, yes, there are seed pods in this first square. Yes, seed pods in the first square. This one looks mostly empty, but if we look really carefully in the corner, the seed pod is in this tiny part of the square. So even though it's just in a tiny little part of the square, yes, this square contains the seed pod. This square contains the seed pod. This square does with these parts in the side. This square does. Here in this tiny, tiny corner, there's some seed pods. Yes, yes, yes. So in this example here, there's 100% cover of seed pods. Of course, the seed pods are not covering the entire landscape, but this is an estimation technique that gives us an idea of the relative abundance of plants on the landscape. So now let's practice with a real life image. How many squares contain vegetation? So pause the video here and count how many squares you think have vegetation in them. Then go to the next slide and watch me do it. Okay. So when we're estimating cover, we're going to use a simple fraction. The top of the fraction, the numerator, is the number of squares with plants. The bottom of the fraction is the denominator. This is the total number of squares. In our purpose, there are 100 squares for the Quadrat. Okay, so let's go through here. This is a square, or this is 4 rows of a Quadrat. We're going to use this as our example. Okay, so in this first square, there are no plants. No plants, no plants, no plants. Now this is a square where we might have dead vegetation, but not any square touching the ground. Or excuse me, not any vegetation in the ground right there. But here we have vegetation in the ground. Here, 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 here. Now, going right along. No, 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 no. This is our transition zone. We would use our fingers to figure this out. Yes. Now look in this square here. Doesn't really look like there's much. But this is an example right here where there is no vegetation really visible, but that is root matter right there from a grass. So this would be a yes. Moving right along. Here's our 4 rows, okay? So we have some decision-making points. When we're thinking about the decision-making points, this is where it's a good idea to have a partner out there with you, because you can count independently and then decide together if your independent counts make sense. Maybe you'll decide to average the independent counts or count again. Just have a critical thinking conversation about it. So if we look at this right here, we can count up all of our check marks. We have 5, 10, 5, 10, 15, 20, 21, 22, okay, 23, 24, 25. I wrote 24 over here. Let's go with that. So I just want to play out the math. You can see here that if there's 40 squares, 24 of them have plants in them, you have 60% cover. Does this make sense? Yes, because if you just eyeball it from the very beginning before I wrote all over it, you can see that about the left half is empty and the right half is full, and that is about 1/2. So that might be your really rough guess. Measuring with the Quadrat turns about half into an actual measurement that can be repeated in future monitoring events. So now in this video, you can watch me measuring percent cover on the landscape in real time. So here we're measuring the head of a social trail. We put 0.0 on the longitude, that white tape, at the intersection between the social trail and the trail we're looking for. Now notice how I'm following each square with my finger. And where I think I see a plant, I'm going to actually press down and see, is that rooted there or is that just litter on top? Okay, once you have that first measurement, you're going to move up the trail. Now place the Quadrat, the edge where my hands are, at the marker. So here it was at 10 feet. So the marker, the Quadrat's going to lay from 10 feet to 12 feet along the longitudinal transect. Okay, see, the thing to notice here is how I'm using my hands and I am really following the squares. And everywhere I think I see a plant, I'm going to press down. And if I'm not sure, I'm going to wiggle my fingers around a bit. If you have a partner, you can be yelling out, yes, no, and that partner can be recording these measurements. Alternatively, you can measure them separately and then average your results. Estimating cover is challenging with a Quadrat. It is especially challenging once we get into looking at richness with multiple species trying to estimate cover. There are physical challenges to using the Quadrat. So for example, here we have lots of yucca in our landscape. And you can see here that I had to basically just spear the Quadrat down on top of the yucca. And I smashed some of the vegetation, so I'm altering the true percent cover because these fronds might not be actually in these squares if I wasn't pressing down on it. So there's a lot of things to consider. Since there'll be one volunteer, one or two, a team working on the same trail month after month, it's really important that you keep notes and you talk about the choices that you make. Are you going to press this down over the yucca? How far are you going to press it down? Are you going to try to prop it up right at the top so you're not actually moving any vegetation? Whatever you do, you need to write down and do it again the next time you measure, and do it again the next time, so that your measurements are consistent. It's not so much the actual numbers that matter, but the change over time. We're really looking for change over time. There's a lot more to know about sampling, and if you're interested in this topic, here's one reference that I really liked. There are many, many more on the internet, and hopefully your answers, hopefully you can get your questions answered by doing some research or asking us. Thanks.